You probably spend, 3 hours a day just dragging data from one glowing rectangle to another.
At least 3 hours, yeah.
Right. Seriously, if you stop and really look at how we spend our days in front of a computer, it's actually kind of shocking.
It is. It's wild.
You are a highly trained professional. You have all this specialized knowledge in your field, and yet you were probably spending hours just, copying a name from an email, pasting it into a CRM tab, downloading some CSV file.
Opening it, resaving it.
Exactly. And then uploading it to a dashboard. It's soul-crushing.
It really is.
But what if your browser could just, drive itself?
Yeah, that's the dream.
Welcome to this deep dive, brought to you as part of the Data Zen AI Podcast by the Data Zen community. I'm thrilled you're joining us today.
Really glad to be here.
If you are listening to this right now, whether you are commuting or prepping for a meeting or just trying to reclaim your Tuesday afternoons, you are our perfect listener. We call you the learner. And our mission today is to explore this massive fundamental shift happening in software right now. We're talking about the transition from a world of manual, repetitive clicks to, intelligent, autonomous web automation.
And it really is a paradigm shift. I mean, we are moving away from the computer as this passive tool that just waits for your physical input.
Right, waiting for you to hit the keyboard.
Exactly. And moving toward the computer as an active participant in your workflow. It's like it is the modern equivalent of escaping the digital assembly line.
I love that. Escaping the assembly line.
Okay.
And to map this out for you, we have an incredible stack of sources on the table today. It's huge.
Oh, it's a massive stack. We are pulling from a 2025 step-by-step guide to Anthropic's Claude computer use, plus enterprise architecture frameworks from, automation giants like Zapier and Make.
And some really dense technical documentation directly from UiPath, right?
Yeah, exactly.
Plus, we're also diving into two fascinating brand new academic papers on machine learning and browser navigation. There's a fantastic breakdown of insurance underwriting workflows by automation anywhere on YouTube.
That one is so good.
It really is. And we've also got some really eye-opening, almost slightly terrifying analyses on AI browser extensions and LinkedIn automation.
Yeah, the privacy stuff is, we'll get to that.
We definitely will.
Yeah.
So we're going to synthesize all of this for you. Okay, let's unpack this. If traditional software is like a bicycle that you have to pedal yourself, meaning, nothing happens unless you exert physical force, the AI agents we are looking at today are like self-driving cars for your browser.
That's a great way to put it.
You just give them a destination and they navigate the traffic. But before we get into the specific tools that are saving engineers and developers and PMs countless hours, we need to draw a hard line.
Right. Definitions matter here.
Exactly. We need to define what exactly makes an AI agent different from the standard AI chat interfaces that, everyone and their mother is already used to using.
That is the perfect place to start, honestly, because the term agent gets thrown around a lot as like a marketing buzzword.
Oh, constantly. Everything is an agent now.
Right. But technically, there is a very distinct evolution here. We are moving from AI that simply answers questions to systems that can actually act.
Act. Okay.
Think about your current workflow with a standard large language model, right? A typical chatbot. You type a prompt, you ask it to draft an email, it generates text on the screen, and you read it.
And then it stops.
The loop ends exactly there. You, the human, still have to highlight that text, hit Command-C, open your Gmail, paste it, add the recipient, and physically hit send.
Right. The AI was just an advisor in that scenario.
Precisely. An AI agent, specifically in the context of web automation, has a completely different capability set. It can actually navigate web pages.
Like on its own.
On its own. It can locate the compose button, click it, fill up the subject line, and execute multi-step workflows autonomously.
So it's about translating a high-level intent into a mechanical action. I'd just say, write me an email about buying this specific monitor. I say, buy this monitor, ship it to the office, and put it on my company card. And the agent goes and physically does the clicking and the scrolling to make that happen.
Exactly. It uses natural language processing to understand your overarching goal. And then it uses a reasoning engine to break that overarching goal down into a sequence of microcomputer actions.
Step 1, step 2, step 3.
Right. And the how behind this is what makes it so revolutionary right now compared to, say, 5 years ago.
Okay, well, walk me through the how.
If we look at the research from Microsoft's AI Clicks initiative, which is one of our key sources today, they highlight the core problem with old school automation. Traditional web automation was incredibly brittle.
Brittle how?
It relied on absolute coordinates or highly specific code identifiers. So, if a web developer updated a site overnight and a submit button moved, like one single pixel to the left,
Or they just changed the color or something?
or its HTML tag changed from button primary to button submit, the whole script would just break. It was completely blind.
Okay, wait, let me push back on this for a second because I want to make sure I really understand the mechanism here.
Sure.
How is this AI agent fundamentally different from just running a recorded macro? Because, years ago, I used to record macros in Excel all the time.
Oh, yeah, the classic macro recorder.
Right. I'd hit the record button, click 3 specific cells, copy them, paste them to a new sheet, and hit stop. Then I could just press a hotkey and it would do it again. Isn't this just a very fancy modern version of a macro? I mean, is it actually looking at the screen?
That is a brilliant question, and the answer gets right to the heart of the breakthrough. Yes, the AI agent is actually looking at the screen. That is the fundamental difference.
Really?
Yes. Your old Excel macro was basically a blindfolded person walking exactly 10 paces forward and 2 paces left, because you told them to.
And if someone moved the desk, I bump into it.
Exactly. If someone put a chair in their path, they would trip over it. They had zero awareness. Microsoft's AI clicks and similar modern frameworks use machine learning, specifically advanced vision models and pattern recognition, to dynamically predict and execute user intent.
So they aren't memorizing coordinate paths for my mouse pointer.
Not at all. They literally take a screenshot of the interface, or they parse the live structure of the web page, and they identify the semantic meaning of the elements.
Wait, what do you mean by semantic meaning?
It means it understands concepts, not just code. It recognizes that a little icon of a magnifying glass means search, even if the word search is nowhere in the code.
Oh.
Or it recognizes that a shopping cart icon means view my items. It bridges the gap between what you, the human, want to do and the mechanical execution, even if the interface changes.
So if Amazon redesigns their entire checkout page tomorrow,
Your old macro is dead.
dead in the water.
Completely. The AI agent, however, just looks at the new page, says, oh, okay, the checkout button is green now, and they moved it to the top right, and it just clicks it.
Okay, that is wild. So if we understand that these agents have, like, virtual eyes, they can see the screen, they understand what buttons functionally do, and they can execute clicks to achieve a goal, where is this actually providing the most value in a real business environment today?
That's the billion-dollar question.
Because I hear this, and part of me thinks it sounds like sci-fi, right? But businesses are deploying this right now.
They absolutely are.
According to IBM's Global AI Adoption Index from our source stack, 54% of businesses using AI reported actual cost savings and operational efficiencies. So where is that money being saved? If you're a manager listening to this, where should you be looking?
When you distill the sources, the enterprise architecture guides we reviewed highlight a few very clear, common use cases where this technology absolutely shines.
Okay, lay them out for me.
The first, and perhaps most prevalent across almost every industry, is data entry into web systems.
Oh, everybody hates data entry.
It's the classic, painful problem of taking unstructured data and trying to force it into a structured web database. Think about a PDF invoice with, like, coffee stains on it.
Or really messy, rambling email from a client.
Exactly.
Yeah.
And you need to put that into specific fields in your accounting software or CRM.
Right, and the documentation on data entry tools specifically brings up a platform called Nanonets for this. And this is fascinating because it doesn't just use standard optical character recognition, or OCR, which, just blindly tries to read text. It uses deep learning to process these documents.
And that distinction is vital. Standard OCR is what you used to get with those old desktop scanners in the 2000s.
Where it would turn an S into a 5 half the time.
Yes. It scans a document, sees the word total, $500, and just turns that into raw text. But it doesn't know what total means.
It has no context.
Exactly. It doesn't know that $500 should specifically go into the amount due column in your database.
Yeah.
Nanonets uses neural networks to understand the spatial and semantic layout of the document.
So it looks at the geography of the page.
Right. It knows that the number next to the word total at the bottom right of a page is usually the final invoice amount. And what's remarkable is that it achieves over 95% accuracy doing this.
Over 95%. That's probably better than a tired human.
It often is. Plus, it's a self-learning system. If it misreads a highly unusual invoice once, and a human corrects it, the neural network actually updates its weights. It improves over time without a software engineer having to manually go in and rewrite the parsing rules.
That's incredible. Okay, so that's data entry. What else?
CRM updates are another massive area. Customer relationship management software is only as good as the data in it, and salespeople notoriously hate doing data entry.
They just want to sell.
Right. So imagine an AI agent that automatically logs your interactions, reads your email threads, enriches lead profiles by autonomously searching the web for their company size and recent news.
Wait, it Googles them for you.
It searches the web, pulls the data, and updates your CRM fields without a human ever touching a keyboard.
Okay, that would save hours.
Exactly. Then there is report generation. This is a huge time sink for project managers. Agents can log into multiple different disconnected dashboards, maybe your marketing analytics in one tab, your sales platform in another, your finance software in a third.
Pull the relevant metrics, synthesize them, and just compile a beautifully formatted weekly summary document autonomously.
Exactly. You wake up on Monday and the report is just sitting in your inbox.
I love the testing and QA use case mentioned in the sources too. Quality assurance automation. Usually, if a company builds a new checkout flow for their website, a human developer or a QA tester has to sit there and click through the site 100 times.
It's so tedious.
Does the credit card field work? Does the error message pop up if I leave the zip code blank? Now, agents simulate human user journeys to find bugs. And because it's an intelligent agent, it can autonomously try different edge cases that a human might literally just forget to test.
It's tireless. And finally, bridging the gap for internal tools. There are so many legacy enterprise systems. Banks and healthcare providers are absolutely full of them that were built 20 years ago and simply do not have modern APIs.
And an API is how two software programs talk to each other in the background, right?
Exactly. If a system doesn't have an API, you can't just plug it into a modern cloud workflow. You are completely stuck.
They're isolated.
AI agents act as the bridge. They interact with the legacy system's clunky, ancient user interface just like a human employee would, literally clicking the old gray buttons, pulling the text out, and feeding it into your modern software stack.
Okay, but there is a massive catch here. And it's something we have to talk about before anyone runs off and tries to automate their whole company today.
Oh, definitely.
The ClickUp source highlights a really surprising statistic. Over 80% of AI initiatives fail.
80%?
80%. That is a staggering failure rate for a technology with this much hype. And the primary reason they cite is that the tools don't share context.
This is the most common trap companies fall into. An AI agent is virtually useless in a vacuum. If I open an isolated AI tab and tell it, draft a response to Sarah's email based on our meeting notes from Tuesday, the agent is going to fail.
Why?
Because it doesn't know who Sarah is, it doesn't have access to your inbox to read the original email, and it has no idea where your meeting notes are stored. It completely lacks context.
It's like hiring a brilliant assistant, putting them in a concrete room with no files and no phone, and telling them to run your business.
That's a great analogy.
If the AI is just a disconnected gimmick that only lives in one browser window, it can't actually complete a workflow. It needs the context of your entire workspace.
Precisely. Contextual AI is what rebuilds the intelligence layer across your tasks, your documents, and your chats. The agent needs permission and technical access to reach into your Google Drive, pull the document, read the Slack message, and then act. Without that connectivity, automation just stalls at the starting line.
Okay, so since context and connectivity are literally everything here, let's get into the mechanics. Let's look at the actual tools and the categories that make this happen. And I want to keep this grounded. If you are a PM or a developer listening right now, and you are looking to build this, what does the ecosystem actually look like?
Right, let's break it down.
Let's start with the foundational layer. Browser automation tools.
These are the under-the-hood engines driving your browser. The academic papers we reviewed heavily feature an open-source framework called Playwright. Now, Playwright wasn't originally built for AI. It was built for developers to write code that tests web apps.
Right, it's been around for a bit.
Yeah, it allows a script to open a browser, navigate pages, and handle things like pop-ups. But recently, developers realized that if you give an AI model the ability to write Playwright commands, you suddenly have an AI that can drive a browser with incredible precision.
And then there's UiPath Computer Vision, which is detailed in their technical documentation. This is a brilliant solution for that legacy system problem you mentioned earlier, specifically when dealing with virtual desktops. Let's say you are working with a Citrix environment.
Oh, Citrix is the perfect nightmare scenario for traditional automation.
Really? Why?
For those who might not know, a virtual desktop environment like Citrix is essentially your computer streaming a live video feed of another computer located on a server somewhere else. You see a desktop, but it's just a video player.
It's basically Netflix, but for Windows.
Exactly. Traditional automation tools, as we discussed, try to read the underlying code of a web page. They look for the hidden HTML tags to find a button. But on a virtual desktop, there is no underlying code for your local machine to read. It's a black box. It's just pixels on a screen.
Oh, wow. So if you tell a standard bot to click the submit button, it looks at the code, sees nothing but a video player, and just fails.
Instantly.
So how did UiPath fix this?
They bypass the hidden code entirely. They use a neural network to analyze the literal image of the screen. It looks at the pixels, just like you and I do. It identifies the UI elements visually, and it uses what they call smart anchors to pinpoint exactly where to click.
Okay, what is a smart anchor?
Let's explain how a smart anchor works, because it's a very clever concept. Imagine trying to tell a friend how to find a specific house in a neighborhood. Traditional automation is like giving them GPS coordinates. If the Earth shifts or the map changes, they're lost.
Right.
A smart anchor is like saying, find the giant oak tree, and the house is exactly 10 feet to the right of it.
Oh, I see.
Yeah. UiPath's vision model looks for a fixed, reliable visual element on the screen, say the text label, username, and uses that as an anchor. It then knows that the blank white box it needs to click will always be directly to the right of that anchor, even if the whole window is resized or moved around the screen. It interacts with the interface exactly how your human eyes and hands do.
That is incredibly clever. Okay, moving up the stack, we have the AI agent frameworks category. This is where Anthropic's Claude computer use comes into play. This isn't just a browser tool. This is a model that operates an entire virtual desktop environment.
Yes, and this is where we really push the boundaries of what these systems can do. The 2025 guide we have outlines how you essentially give Claude a high-level task.
Yep.
You spin up an environment, and Claude literally takes control of the virtual mouse and keyboard.
Like it's a ghost in the machine.
It kind of is. It takes a screenshot of the desktop, analyzes it, decides where to move the cursor, clicks, types, and then takes another screenshot to verify what happened. It is operating the machine exactly as a human would.
But I want to be really clear about something, because the first time I read this, I panicked a little. You don't just download this and let it run wild directly on your personal laptop, right?
Oh, absolutely not. And that is a critical, non-negotiable safety point. In almost all enterprise setups, an agent like Claude computer use is run inside a secure, isolated environment called a Docker container.
Okay, for the non-engineers listening, what exactly is a Docker container?
Think of your computer's operating system as a giant office building where all your files, your photos, and your passwords live.
Okay.
A Docker container is like building a completely sealed, soundproof, bomb-proof glass box in the lobby of that building.
A glass box?
Yeah. You can put a worker, the AI agent, inside that glass box. You can pass them a laptop with a web browser, and they can do whatever work you ask them to do. But they cannot open the door of the glass box. They cannot access the rest of your office building.
So they can't get to my photos or my tax return.
Exactly. They are physically walled off from your host operating system. So if the AI agent hallucinates or makes a mistake or accidentally tries to delete a crucial system file, it only damages the fake temporary environment inside the glass box. Once the task is done, you just vaporize the box and start fresh. It protects your actual hardware and personal data.
That makes total sense. Okay, let's talk about the no-code automation tools. These are platforms like Zapier and Make. I like to think of them as the universal translators of the internet.
I love that analogy.
Let's use it. If the internet is the United Nations, every piece of software speaks a different language. Gmail speaks one language, Slack speaks another, your CRM speaks a third. Zapier sits in the middle. It catches the payload from an incoming email, instantly translates it, and hands it to Slack in a format Slack understands.
That's a perfect way to visualize it. Make is a platform that allows you to string together, say, OpenAI's ChatGPT, your Gmail account, and your Slack workspace completely visually.
You don't write code.
No code at all. You drag and drop bubbles on a screen to create a workflow without writing a single line of Python or JavaScript.
Zapier is very similar, but their enterprise guides really emphasize what they call cross-team orchestration. They were trying to solve that 80% failure rate we talked about earlier.
Right, the context problem.
Exactly. They want to take these isolated AI experiments that, one guy in marketing is doing and turn them into robust, company-wide workflows that share context across departments. And within this no-code space, you also have specialized data collection tools like FormStack, JotForm, and Formaloo.
Those are really interesting.
They use AI to look at a natural language prompt like, build me a form to collect patient intake data. And they instantly generate the web form, and then use AI to process the incoming unstructured data when people fill it out.
It speeds up deployment massively. Next, we have to look at browser extensions. This is the local approach, and we need to draw a sharp distinction here between full AI browsers and AI extensions.
Okay, what's the difference?
An AI browser, like Arc or Brave, is a completely separate piece of software. If a company wants to adopt it, they have to force their employees to completely migrate. You have to move all your bookmarks, transfer your passwords, migrate your history, and learn a whole new interface.
Which is a massive friction point. I mean, if you are an IT manager at a Fortune 500 company trying to get security approval to install an entirely new web browser across 10,000 employee laptops, that is going to take a year of meetings.
At least a year. Extensions, on the other hand, like Monica, Bardeen, or Composite, bypass that friction. They just install as a little plugin inside your current Google Chrome or Microsoft Edge browser. The user stays in their familiar environment.
And the composite extension, which is detailed in our sources, is really interesting because it executes multi-step workflows completely locally on your machine.
Yes, meaning the data never leaves your laptop. We will definitely dig into why that local execution is so vital for privacy in a minute.
We absolutely will. The final category to understand is RPA, or Robotic Process Automation Platforms. These are the enterprise heavyweights. We're talking about platforms like Boomi, which is used to wrangle massive legacy on-premise servers, MuleSoft, which is designed for highly sensitive, highly regulated data environments like international banking or healthcare records,
And Highland IDP for massive scale enterprise document processing. These aren't really for the solo entrepreneur. These are the tools running the backbone of major corporations.
Okay, so it's easy to sit here and list tools and categories all day. But what does this actually look like when the rubber hits the road? How does the daily life of a worker change?
That's where it gets real.
Let's walk through some real-world examples from our stack of sources. And I want to start with the insurance underwriting example from the Automation Anywhere YouTube breakdown because it perfectly illustrates the end-to-end power of combining these tools.
Insurance underwriting is a fantastic, highly complex use case. If we connect this to the bigger picture, traditionally it is notoriously slow, heavily reliant on dense spreadsheets, and incredibly manual.
Right. If you've ever worked in or around insurance, you know the pain. Missing documents, manual data entry, the endless swivel chair work where a person is literally swiveling their chair between two monitors, reading a PDF on the left screen, and typing it into a web portal on the right screen.
The swivel chair is the enemy of efficiency.
It really is. So here is how an AI agent workflow completely reimagines that process. First, an email arrives in the inbox from an insurance broker with a new submission. The AI agent constantly monitors that inbox, intercepts the email, and uses natural language processing to read the intent.
It understands the context.
Exactly. It understands, okay, this isn't a spam email and it's not a general question. This is a request for a new insurance quote. It automatically strips out and downloads all the attachments. And we are talking about a mess of files, PDFs, JPEGs of property damage, sometimes even scanned handwritten documents.
And immediately, before it does any deep analysis, the agent connects via an API to the insurance company's CRM. It searches the database to see if this specific property or client already exists in the system.
It checks for duplicate opportunities to prevent two different underwriters from accidentally quoting the exact same risk and wasting company time.
Exactly. Then the heavy lifting starts. It uses a large language model to act as an intelligent extractor. It reads through the messy broker email and all those attachments we mentioned, and it specifically hunts for the core data fields required for a quote.
What kind of data?
It extracts the risk address, the total insured value, the year the building was constructed, the occupancy type, and any prior claims history. Then, it takes all that extracted data and cross-checks it against the insurance company's specific appetite grid.
The appetite grid is basically the rule book, right?
Right. It tells the system what kinds of risks the company is willing to insure.
So the AI agent does the math. And here is where the autonomous decision-making really happens. Based on that analysis, the agent can instantly generate a polite, professionally formatted declination email back to the broker if the property is out of appetite.
Say it's a wooden building in a high wildfire zone.
Yeah, exactly. It explains exactly why they are declining it.
Yes.
Or, if it is an appetite, the agent autonomously opens the internal pricing portal, auto-populates the complex pricing spreadsheet with all the extracted variables, calculates the technical premium, and drafts an underwriting narrative summarizing the risk.
But let me pause you there because the real world is never that clean.
Never.
What if data is missing? Brokers are human. They forget to attach the claims history or they leave the construction type blank. Does the bot just crash, throw a massive error code, and shut down the whole system?
This is exactly what I was wondering when I watched the breakdown. And the answer is no. And that is the beauty of intelligent agents versus brittle macros. The workflow doesn't break.
It adapts.
It adapts. If the AI agent is filling out the pricing sheet and realizes a mandatory piece of data is missing, like the square footage, it doesn't crash. It relies on its reasoning engine. It automatically drafts a new email back to the broker saying, "Thanks for the submission. To provide a quote, we need the total square footage."
Wow.
It sends the email, and then it simply pauses that specific workflow. It puts it on a virtual shelf. When the broker replies 3 hours later with the square footage, the agent reads the reply, pulls the workflow off the shelf, fills in the missing field, and picks up exactly where it left off. Zero human intervention required for the entire data collection phase.
It's incredible. The human underwriter just receives a perfectly packaged, fully priced submission, complete with a summary narrative, ready for their final intellectual review.
Which naturally brings up a massive question that we have to address right now. When you describe a system that efficient, the immediate fear is job loss.
Oh, of course.
Will AI agents like this replace operational roles?
Right.
If I'm an underwriter, does this tool get me fired?
It is the most important question we can ask today. But if we look at the data and the current implementation trends, the answer is highly nuanced. Let's look back at the exact example you just gave. The AI agent didn't fire the underwriter.
No, it didn't.
The AI agent, as it exists today, cannot assess the complex gray area nuance of a highly customized commercial risk policy. It doesn't have the gut instinct or the strategic foresight of an expert. What the AI did do was take away the swivel chair data entry. It handled the triage, the extraction, the basic math, and the badgering of the broker for missing files.
It removed the copy-pasting. It removed the soul-crushing part of the job.
Right. It frees the human to actually use their highly trained brain. It shifts operational roles from being what we call data movers, people whose primary job is simply transferring information from system A to system B to data reviewers and strategic decision makers. The roles won't necessarily vanish, but the daily tasks defining those roles will change dramatically. The underwriter goes from spending 80% of their day doing data entry and 20% analyzing risk to spending 100% of their day analyzing complex risks.
That is a very optimistic but very plausible shift. Now, let's look at a totally different example from our sources, and this one is about accessibility.
I love this one.
It comes from an academic paper published in the International Journal for Multidisciplinary Research. Researchers built an AI agent using Playwright and a framework called LangChain, specifically designed to help visually impaired users navigate the web.
This is a profound application of the technology. We spend so much time talking about corporate efficiency and ROI. It's easy to forget that this technology can be fundamentally life-changing for accessibility.
Okay, before we get into what the agent actually did, I need an ELI 5 explained. Like I'm 5 for LangChain. You mentioned Playwright is the browser engine. What is LangChain? And if I already have an AI model like ChatGPT, why do I need a chain? What is it's chaining together?
It's a great question. If a large language model like the brain behind ChatGPT is just a brain in a jar, it can think, but it can't interact with the world. LangChain is the nervous system that connects that brain to tools. Let's say you ask an AI, what is the weather in London? And then add that to my database. The AI brain doesn't inherently know how to check a live weather API, and it doesn't know how to write to your specific SQL database. LangChain allows you to chain these things together. It takes the user's prompt, passes it to the AI brain. The brain decides, I need to use the weather tool. LangChain facilitates that connection, gets the weather data, passes it back to the brain.
Like a messenger.
Exactly. The brain says, now I need to use the database tool. LangChain facilitates that connection. It chains the reasoning of the LLM to external actions and memory.
So it's the infrastructure that lets the brain actually use its hands.
That's a great way to put it. So in this academic study, they chained an LLM brain to the Playwright browser automation tool.
And the task they gave this agent was incredibly complex. They wanted it to navigate to Amazon.com, search for a specific item, a Samsung Galaxy S23 Ultra 5G, find the correct listing among all the sponsored ads and accessories, add it to the cart, and proceed all the way through the checkout process.
Which is hard enough for a sighted person sometimes.
Exactly. And the visually impaired user can initiate all of this just by speaking a single natural language command into a microphone.
What's deeply impressive about this study is the performance metrics. The AI agent completed this multi-step e-commerce workflow with 92% accuracy.
92%. Wow.
Furthermore, It reduced the task completion time by 60% compared to a user manually trying to navigate with a traditional screen reader.
And what's wild about Amazon is that their layout changes constantly. They run A/B tests, they move the Buy Now button, they change how sponsored products are displayed. A traditional screen reader gets incredibly confused by dynamic layouts because it relies on reading the HTML structure in a strict linear way.
Right, it reads code top to bottom.
But because this agent uses dynamic perception, parsing the code but also using vision to gracefully handle dynamic changes, it doesn't break. If the Add to Cart button turns yellow and moves to the bottom of the screen, the agents still find it.
That is the realization of a true self-driving browser. It adapts to the road conditions.
Okay, here's an example that I know you are going to absolutely love. It's from the second academic paper in our stack, published by the SAI, and it's about integrating machine learning directly into RPA scripts for enterprise data validation.
Oh, this one is absolutely brilliant. What's fascinating here is it highlights the difference between a dumb robot and a smart agent.
Okay, tell me more.
Because traditional RPA, the old school enterprise bots we talked about, are incredibly stubbornly literal. If you write a script that tells an RPA bot to scrape a daily sales report from a web portal and dump that data into your central Oracle database, the bot will do exactly that, thousands of times a second.
Right.
But it has no critical thinking skills.
Ah.
If the web portal glitches and all the sales numbers are suddenly formatted as dates, or if half the data is missing, the bot doesn't care. It will blindly shovel that corrupted dirt straight into your pristine database.
Which completely ruins your database.
Yeah.
You end up with a massive data integrity disaster that takes weeks to clean up. So how did the researchers fix it?
They built a pipeline that intercepts the data before it ever touches the database, and it applies 3 different, highly specialized machine learning models to validate it. They act as a series of intelligent checkpoints.
Okay, walk me through the checkpoints.
First, they use the Pandas library in Python. Pandas isn't AI, it's a data manipulation tool. Think of it as a meticulous librarian. It takes the messy web data, structures it into neat rows and columns, normalizes the date formats, and gets it ready for inspection.
Okay, so the data is neat. Then what?
Then the actual machine learning takes over. The first checkpoint is an algorithm called a random forest.
Okay, pause. What on earth does a random forest do?
A random forest is a type of supervised learning algorithm. Supervised means you have to train it on historical data that has been labeled by humans as either valid or invalid. Imagine a board of directors making a decision.
Okay, I'm picturing a boardroom.
Instead of one person deciding, you have 100 different directors looking at the same problem from slightly different angles. Each director is a decision tree. When a new row of data comes in, every single decision tree looks at it and votes on whether it looks structurally sound based on the historical patterns they learned. The forest then tallies the votes and makes a final prediction.
So it's basically checking the data against all the known rules of the past. It's the bouncer at the door checking IDs to make sure everything looks legitimate.
Exactly. But a bouncer only catches obvious fakes. What if a piece of data looks technically correct? All the formatting is right, but it's just bizarre contextually. That's where the second checkpoint comes in, the isolation forest.
An isolation forest. Sounds lonely.
It is. This is an unsupervised model, meaning you don't need labeled historical data. An isolation forest is brilliant for anomaly detection.
Give me a visual for this one.
Imagine a massive scatter plot graph of data points on a wall. Most of your normal daily data points are clustered tightly together in the center. An anomaly, a weird, unexpected piece of data, is a point way out in the distance by itself. The isolation forest algorithm tries to isolate points by drawing random straight lines across the graph.
Like drawing fences.
Yes. Think of it like trying to fence in a group of people in a field. If everyone is standing in a tight group, you have to build a lot of complex fences to isolate just one person. But if there is a hermit standing way out in the corner of the field by himself, you only need 1 or 2 fences to isolate him.
Ah, I see.
The algorithm measures how many fences or splits it takes to isolate a data point. If it takes very few splits, the algorithm flags it and says, this point is an anomaly. It's sitting out by itself. Something is wrong.
So the random forest checks the formatting rules, and the isolation forest looks for the weird outliers that a human might miss.
Right. And the final, ultimate layer of protection is the autoencoder. This is a neural network that looks at the macroscopic picture. It takes a whole day's worth of data, compresses it down into a tiny mathematical representation, and then tries to reconstruct it back to its original form.
Like zipping and unzipping a file.
Sort of. If the daily report is a normal Tuesday, it reconstructs perfectly. But if the report has some massive, unusual deviation, like a sudden 80% drop in sales volume across all regions that breaks the overall pattern of the data, the neural network won't be able to reconstruct it properly. The math fails.
And then what happens?
When that happens, the system generates a proactive, high-priority alert to a human manager, and it halts the data load entirely.
That is incredibly heavy-duty validation, and the results they publish speak for themselves. According to the paper, processing 8,500 daily records went from taking a human 120 minutes of manual review down to just 15 minutes. And the actual data loading phase went from 4 hours down to 40 minutes.
It's an 87.5% reduction in processing time, while simultaneously improving the quality and safety of the data entering the enterprise database. It is a win on every front.
Let's bring it back to a slightly simpler, very approachable example for our listeners who might not be building neural networks tomorrow. The Claude Computer Use 2025 guide provides a really simple recipe for automating forms. You essentially point the Claude agent to a local CSV file on your machine, just a basic spreadsheet of contacts, and you give it a prompt.
Read this file, and for every row, navigate to this specific web form, fill in the first name, last name, email, and company, and hit submit.
Right. And what makes this powerful, again, is the vision capability. Imagine running a rigid script to do this. Halfway through your list of 500 contacts, the website you were submitting to decides to pop up a massive banner ad or a subscribe to our newsletter modal right in the middle of the screen.
Oh, I hate those. A rigid script would fail instantly because the submit button is hidden behind the pop-up. The script clicks the ad by mistake, navigates away, and crashes entirely.
But Claude doesn't crash.
No, Claude simply sees the pop-up. It analyzes the screenshot, recognizes that an unexpected modal has appeared, identifies the tiny X or close button in the corner of the modal, moves the mouse, clicks the X to clear the obstacle, and then smoothly resumes filling out the form.
It reasons through visual obstacles exactly how a human would.
Exactly.
These examples clearly highlight massive shifts in how work gets done. Let's explicitly summarize the benefits that you, the listener, can expect to see if you start advocating for and implementing these tools in your own workflows, because this is how you get buy-in from your team.
The first, and most obvious, is massive time savings. We've seen workflows go from taking multiple days down to minutes in the insurance underwriting example. We saw an 87.5% time reduction in the academic data processing model. Automation reclaims the most valuable asset you have, hours of your day.
The second benefit is reduced human errors and higher accuracy.
Humans suffer from cognitive fatigue. It's unavoidable. If you ask a human to stare at a spreadsheet of 8,500 records for 4 hours, they're going to make a typo. They're going to copy the wrong cell and paste it into the wrong row.
Oh, I've done it a million times.
Systems like NanoNets achieve 95% document processing accuracy consistently, whether it is 9:00 a.m. after a coffee or 4:30 p.m. on a Friday. And the machine learning validations, like the isolation forest we discussed, will catch incredibly subtle numerical anomalies that a tired human eye would simply skim right over.
But the third benefit is where my mind really got blown reading these sources. It's not just about doing things faster or with fewer typos. It's about achieving fundamentally better outcomes. And the LinkedIn automation source illustrates this shift perfectly.
Yes, this is a crucial pivot in how we think about the philosophy of automation.
So let's look at LinkedIn. Previously, people used cloud simulators tools like Phantom Buster or Expandy. These tools ran on a remote server and just blindly blasted out connection requests. You'd set it up to spam 400 people a week with the exact same message. Hi, I see we are both in the tech industry. Let's connect.
Which is exactly why everyone hates LinkedIn automation. It degrades the platform. It's generally terrible, generic spam that annoys the recipient.
Exactly. But the source profile is a user named Priya, who switched from that old-school spam cannon method to using true AI agents, specifically a platform called Cotera. Instead of just automating the repetitive clicking, the AI agent works outside of LinkedIn to build a strategy. It analyzes competitor data, it tracks which prospects are actively engaging with relevant content, and it tells Priya exactly who to target and what specific topics they care about based on their recent posts.
That's way smarter.
Because of this high-level intelligence, Priya dropped her output drastically. She went from sending 400 blind requests a week to sending just 60 highly targeted requests a week.
She intentionally slowed down the mechanical output.
She slowed it way down.
Yeah.
But here is the kicker. Her connection acceptance rate skyrocketed from a miserable 28% up to 71%. Her response rate on first messages almost tripled. And most importantly, the actual business outcome total meetings booked went up by 15%, even though she was reaching out to a fraction of the people.
This is the exact takeaway for the listener. Automation isn't just about doing the same bad behavior faster. Using a robot to send spam faster just creates more spam. True AI agents allow you to do better behavior at a manageable scale. It shifts the automation from clicking buttons rapidly to automating the deep research and strategy.
Which naturally brings us to a massive ethical and practical question. Where should automation stop? We clearly have the technology to automate almost anything on a screen. If Priya wanted to, she could have the AI draft the message, send the connection, and even reply to the prospect automatically.
She could.
But should we? The LinkedIn article brings this up perfectly because LinkedIn actively bans cloud simulators. They use sophisticated algorithms to detect and ban accounts that fake human sessions. They fundamentally do not want robots talking to robots.
This raises an incredibly important point about the intrinsic value of authenticity. Just because you can automate a click doesn't mean you should. We have to be strategic about where the machine ends and the human begins. If a task requires authentic human connection, high-stakes empathy, or genuine relationship building like closing a major enterprise deal, or handling a delicate customer service escalation.
Automation should stop at the research phase.
Exactly. Be the researcher, not the communicator. Let the AI agent do the heavy lifting. Gather the data, summarize the person's profile, identify their pain points, and suggest talking points. But the human being must be the one to actually look at that research, internalize it, reach out, and execute the connection. When you attempt to automate empathy, you inevitably destroy trust. And once trust is broken in a business relationship, no amount of efficiency can repair it.
That is a perfect place to draw the line. Automate the busy work, automate the data moving, but fiercely protect and keep the human connection authentic. Now, of course, it is not all smooth sailing.
No, it never is.
We have to talk about the reality check here. Handing over the keys to your browser comes with significant risks and limitations. Let's start with reliability. We've praised AI vision, but what actually happens when a website is just an absolute mess?
It's true. While we established that AI vision and semantic selectors are highly adaptable and light years ahead of old scripts, they are not infallible magic. The modern web is incredibly messy.
Right.
Think about sites with infinite scrolling pages that dynamically load content, or complex drag-and-drop interfaces like a Kanban board, or heavy client-side dynamic rendering where the elements on the page are constantly shifting based on mouse hovers.
So the AI gets confused.
These complex interactions can still cause agents to hallucinate, misinterpret the visual layout, click the wrong thing, or just stall out completely in an endless loop of confusion. You cannot simply set it and forget it on highly complex, constantly changing interfaces. It requires monitoring.
And then there's the elephant in the room.
Right.
Security and data privacy.
Oh, yeah. This is big.
The Incogni analysis we sourced has a truly terrifying statistic that made me double-check my own browser. They analyzed 442 AI-branded Chrome extensions currently available on the market. 52% of them, more than half, actively collect user data. And 29% collect personally identifiable information, or PII.
That is a staggering vulnerability, and it stems from the fundamental nature of how these browser extensions are forced to work. If you want an AI extension to automate your web tasks, to read your emails or fill out your forms, you have to grant it the standard browser permission to read and change all your data on the websites you visit.
Right. It physically needs that access to see the page and click the buttons.
But giving an extension built by a third-party vendor that level of sweeping access is highly, highly dangerous if you do not implicitly trust their security infrastructure.
Because if they are compromised, or if they have malicious intent, they can see your logged-in banking session, your proprietary company, documents in Google Workspace, your private emails, literally everything rendered in that browser window.
Everything.
Which brings us to another critical question for the managers listening. Is it actually safe to let AI interact with your core business systems? Like, what is the danger of an AI agent just going rogue in your Salesforce instance and accidentally deleting 5,000 customer records?
It's a valid fear, and the safety depends entirely on your architecture and your governance protocols. If you just give a raw, experimental, open-source AI model your master admin password to Salesforce, no, it is absolutely not safe. It is a disaster waiting to happen. But if you architect it correctly, it is highly secure. This is why mitigation strategies are critical. First, Prioritize local execution tools whenever possible. We mentioned the composite extension earlier. It executes workflows locally in your browser and has a strict zero data retention policy. Nothing is sent back to their cloud servers to be analyzed.
Okay, and for the engineers building custom solutions, what are the rules?
Never, ever hard code your API keys or passwords directly into the script the agent is running. Keep them secured in environment variables. Utilize those isolated Docker containers we talked about with Claude to sandbox the agent's operating environment. But most importantly, whether you are using an enterprise orchestration platform like Zapier, which operates under strict SOC 2 compliant security frameworks, or building it yourself, you must enforce the principle of least privilege.
Give it only the keys it needs for today's job.
Exactly. Don't give an AI agent overarching admin rights to your production database on day one. Limit its access to only exactly what it needs to perform its specific, narrow task. Create a dedicated bot user account with restricted permissions. And always run new agents in a safe, isolated test environment for weeks before letting them touch live customer data. Treat the agent with the same rigorous security audits you would apply to any human employee.
Which leads right into the final safeguard, the need for human supervision. I really love how the automation platform handles this specifically. They've built in what they call a human-in-the-loop module.
It's a brilliant, essential design pattern for enterprise automation. In a human-in-the-loop system, the AI does all the heavy lifting. It monitors the inbox, reads the complex email, extracts the data, checks the CRM, and drafts the detailed response or prepares the new database entry.
It does 99% of the work.
Before anything actually executes, before the email is sent or the database is permanently altered, the workflow automatically pauses.
It is a red light.
It hits a red light, and it pings a human supervisor on Slack or Microsoft Teams. It sends a neat summary. Here is the original email, here is the data I extracted, and here is the action I am about to take. Do you approve? The human takes 5 seconds to review the summary, relies on their judgment and expertise, and simply clicks a green approve button or a red reject button right inside Slack.
If they hit approve, the agent instantly fires off the execution.
It allows you to maintain the blistering speed and scale of AI processing while preserving the critical safety net of human judgment.
You treat the AI exactly like a highly capable, extremely fast junior employee. They can do the work, but they need their manager to sign off on the final deliverable before it goes out to the client.
That is the exact mental model to use.
Well, looking at the clock, that brings us to the end of our journey today. I want to sincerely thank you, our listener, for joining us on this deep dive into the underlying mechanics and the practical reality of AI web agents. We've moved far beyond just chatting with bots.
It really is an incredibly exciting time in technology. We are actively watching these tools transition from fragile, brittle scripts that break when a button moves into practical, intelligent, everyday utilities that actually respect our time and fundamentally augment our capabilities as workers.
We covered a massive amount of ground today, from the technical weeds of academic machine learning models like random forests, all the way to practical no-code Zapier workflows and the philosophy of authentic connection. If you are listening and you want to explore all the specific tools, the extensions, and the detailed real-world examples we discuss, you can read the full, comprehensive companion article for this deep dive. Just head over to your browser and go to datazen.top/podcast AI 20.
I highly recommend checking it out. It's a fantastic resource to start mapping out and building your own agentic workflows.
And please, if you found this deep dive useful and it sparked some ideas for your own team, click the heart icon on the article. It really helps us out. And be sure to subscribe to the Data Zen AI Podcast so you never miss an update, because as we've seen, this technology continues to evolve at lightning speed.
Before we sign off, I want to leave you with one final, slightly provocative thought to mull over. We've spent this entire hour talking about AI navigating the web as it exists today. A web heavily built with colorful visual buttons, drop-down menus, and forms designed specifically for human fingers to click and human eyes to read.
Right.
But consider this. If, in the next 3 to 5 years, the vast majority of web traffic becomes AI agents doing chores on our behalf, how will the fundamental design of websites change when their primary audience is no longer human?
Wow. A web built natively for machines. No buttons, just data streams. Something to definitely think about. Until next time.